Today we are doing not this. So there's that. We're doing arcs and angles. Okay. So you'll see that on the notes sheet that you have right here. All right. So everyone's focused. Here we go. We have talked about central angles before, where the vertex of the angle was the center of the circle, right? But today we're talking about three other types of angles: inside angles, outside angles, and inscribed angles, which are on the edge. Okay. So the first one is angles inside the circle theorem. If two chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle. So that means, for example, if I'm looking at this angle 1 right here, I need to find, first of all, the sum of the intercepted arcs, which would be AB and, what's this one? DC, right? So fill that blank in. I find the sum, which means I'm going to add them up. And once I find that sum, I'm going to find half of it. So that's why I have this 1/2 in front of those parentheses. So again, it's angle equals half, parentheses, arc plus arc. Okay? Same thing with angle 2. Here's another angle. Angle 2 equals half of this arc. What's this arc called? AD plus the other arc, BC. Alright, so add up the arcs, cut them in half. That's your interior angle, inside angle. Okay, so example 1, let's do this. What is our angle on the inside here? Nope, angle on the inside. X, okay, because that's what we're looking for. So X, so always write the angle first, then equals, and we're always trying to find what? Half, so I got to put 1/2, parentheses, and now I'm going to find the sum, which means I'm going to add the two arcs, which are what plus what? 130 plus 156. So that's always how you set it up when there's an angle on the inside. Angle equals half, parentheses, arc plus arc. Okay? Parentheses, yeah. Now, what do I do with these two numbers on the inside? Add them up. 130 plus 156 is? Okay, so it's 1/2, 286. And now I just got to find half of 286. You can either multiply the half, or you can just divide 286 by 2. So 286 over 2. What do I get? $143. Okay. Degrees. Okay, so I know you could definitely add two arcs, divide them by 2. But look at example 2. What's different about example 2? Instead of X, there's a Y, and instead of being on the inside, it is on the outside. Again, what we're missing is not the inside angle, we are missing an outside arc. But since there's an inside angle here, we're going to use the same formula. So what do I always put first? The angle. What's the angle here? Not Y. Yeah, the angle is still on the inside. What is it? 108, right? So let's write that down. 108 equals, and what comes next? 1/2 parentheses. And what are my two arcs that I'm adding? Y and 68. So Y plus 68. Do you see how sometimes the variable is not by itself on the left? Sometimes it's over here, right? Now we need to solve this, and you should be able to solve this right now on your own without my help. Do you think you can do that? Okay? All you're trying to do is move stuff out of the way, so y is by itself. So, I should get rid of this 1/2 first. How do I get rid of a 1/2? Multiply by 2 times 2. Okay, if you're trying to get rid of a 1/2 fraction, you do times 2, cancel out, and on this side, times 2. What's 108 times 2? 216 equals y plus 68. And now I have one last step. What do? Okay, subtract 68. What is 216 minus 68? All right, so 148 equals y. Degrees. All right, so those are two types of problems you'll have when it comes to interior angles. Talk about angles on the outside, okay? So does everyone see the first two examples, the angle was inside. Look at these three examples. Angle 1, 2, and 3 are outside of the circle. There's three examples. You have a tangent and a secant, like example 1 here. Two tangents, like example 2, or two secants, like example 3 here. And it's very similar to the last one. On the last one, we added the arcs and found half. Now we're going to add, instead of adding, we're going to subtract. Okay. So the measure of the angle formed is half. Instead of sum, this is going to be difference, which means we're going to subtract. Okay. Last time was half of the sum on the inside. This time it's half of the difference on the outside. Okay. So my angle over here is angle 1. So angle equals half. And it's always big arc minus little arc. What's the name of this big arc right here? BC. And then minus, what's the small arc? AC. Yeah. Cool. What if it's two tangents? Same idea. Angle equals half. What's the big arc named? PQR, since it's a major arc, minus the smaller one, which is PR. Well, they would both be PR. One of them has to be bigger, so it's PQR. All right, and then for angle 3, that angle equals half. The big arc is XY. What's the small arc? WZ. Okay, flip it over. Let's do some examples of those. All right, so once again, we're setting it up. Angle equals half, parentheses. So what's the angle here? What's this angle? X equals what? 1/2, parentheses. What's the big arc? 162. And remember, since it's outside, we're subtracting. What's the small arc? Oh, 161. All right, hold on. 161. My bad. And then minus the small arc is 67. All right, now let's start in the parentheses. 161 minus 67 is 94. So 1/2 of 94, 94 divided by 2, either way, is what? 47 degrees. Okay. So, get the idea? Outside equals inside, outside angle equals big arc minus little arc. All right, now this one, what's the angle? X again. Equals what? No, 1/2, parentheses, what's the big arc? 238. What's weird about this? Okay, we don't have the other arc, which might make you think, what can we do, right? But at least one of us has seen already, since these are two tangents, there's only two arcs. And what do these two arcs add up to for a whole circle? 360. So you need to figure out this missing arc by doing 360 minus the big arc, 238. What do I get? Thanks for helping out. 122. 122. Now that we have that missing arc, now we're going to do 238 plus or minus? Minus 122. Okay? What is 238 minus 122? (116). So 1/2 of 116 is what? 58 degrees, right? Okay, example 3. What's different about that? They give us the outside angle, but we're missing an arc. But we set it up the same way. What's the outside angle? Out here. 35 this time equals what? 1/2, parentheses, what's the big arc? 95 minus the small arc is x. Okay. So we want to solve for x. We need to get rid of the 1/2. How do I get rid of the 1/2? Times 2. So times 2 cancels out the 1/2. Times 2, what's 35 times 2? 70 equals 95 minus x. How do I solve for x? What y'all think? What? Not plus, but because it's already positive. So we're going to subtract 95. What's 70 minus 95? What? Negative 25 equals, and what do I bring down here? Negative x, right? The negative doesn't go away. So we have a negative 25 equals a negative x. That's not it, because we need a regular positive x, right? How do I get rid of the negative sign? Anyone know how to get rid of a negative? What? Multiply or divide by -1 will cancel out the negative. Because, and I usually do divide. So dividing by -1, you know 2 negatives when you're dividing cancel out. Cancel, cancel. And you have to do it on both sides. So the negative in front of the 25 cancels out. So it's really just 25 equals x. Okay? So if you have a negative you're trying to get rid of, divide by -1 to get rid of it. Now I'll tell you, that's probably the hardest part of this, because the last little section here, in my opinion, is the easier part. The front of the page, we were talking about inside angles. We just finished outside angles. Now we're talking about angles on the edge. They're called inscribed. Okay? An inscribed angle, is an angle whose vertex is on a circle. So see how E is on the edge? And whose sides contain chords of the circle. Now let's name that angle. What is the name of this angle? Angle DEF is an inscribed angle. Okay? So, what do we do for inscribed angles? It says the measure of the inscribed angle is 1/2. That's it. The inscribed angle on the edge is 1/2 of the arc that it intercepts. So look at this example. ABC, this angle right here, is 1/2 of the arc, which is called what? Arc AC. Angle's kind of what? Cool. All right. So example 1, find measure ABC. I'll put an X right here. Now I'm looking for that X angle. So X equals, just half. 1/2 of the arc. What's the arc? 120. So just what's 1/2 of 120? 60. Easy, right? Hopefully. If it's on the edge, it's just half of the arc. That's it. No adding, no subtracting, just half. But what about example 2? What if you know the angle, but you're missing the arc? So angle equals half the arc. How do I solve for x? What do I do to get rid of the half? Times 2. 35 times 2? 70 degrees. So if you have the inscribed angle, you double it to get the intercepted arc. Last one, let's call that x. How do I figure out this inscribed angle? This x is the center, but whatever. You can call it something else if you want. But half of 60 is the inscribed angle. What is that? 30. Okay? So, those are the 3 types of angles you learned today. I know your assignment is a little bit beefy, but you got today and Monday to finish it. Tear off the assignment from the notes. Use your notes to do that. And make sure you're turning in missing work. And we'll go over your quizzes Monday or Tuesday. We'll see.